Welcome to today's discussion. We are going through Form 4 Chemistry and the topic Organic Chemistry. And the question we have is about detergents. And we know that during washing, water alone cannot remove dirt, and therefore to increase the ability of water during washing we add substances known as detergents. What are detergents? Detergents are substances that improve the cleaning properties of water. We have two types of detergents. We have soapy detergents. We also have soapless detergents. Soapy detergents are commonly known as bar soaps. The question we have reads, the structures below represents two cleansing agents. We have the one that contains the carboxylate part and the one that contains the sulfonate part. In this case, the first one, which contains the carboxylate part, is known as the soapy detergent, while the one that has the sulfonate group, we call it soapless detergent. In the table below, give one advantage and one disadvantage of using each one of them. The soapy detergent, the advantage is that it is cheaper. It's cheaper compared to the soapless detergents. The disadvantage of using the soapy detergent is that it forms scum with water containing calcium ions and magnesium ions. We have the soapless detergent, and the advantage of this detergent is that it does not form scum with water containing either calcium or magnesium ions. Does not form scum with water containing calcium and magnesium ions. Remember, we have two types of water hardness. We have permanent water hardness, which is caused by calcium or magnesium ions. We also have temporary water hardness that is caused by bicarbonates of magnesium and calcium. The disadvantage of this type of cleansing agent is that it is expensive. The reason why it is expensive is because these detergents are made from petroleum products or vegetable oils, which are very expensive. We move down to part C. Under certain conditions, ethanoic acid, that is C2H4O2, and ethanol with the molecular formula of C2H5OH react to form a sweet-smelling compound. Remember, when we have alkanoic acids reacting with alkanols, they form sweet-smelling compounds known as esters. Before we move down to the questions, we have C2H4O2, which represents ethanoic acid. We can reorganize it as follows. We have CH3, then C-double-O, then we have H. If you bring this H to this 3H, then it becomes 4. And then, of course, we have two oxygens here and two carbon atoms. We go now and look at the questions. Roman 1. What is the general name of the compound to which the sweet-smelling compounds belong? The sweet-smelling compounds belong to a group of compounds known as esters. Esters are formed through esterification, and esterification occurs when an alkanoic acid reacts with an alkanol. Roman 2. Write the formula of the sweet-smelling compound. In this case, we are going to have ethanoic acid, CH3, COOH, reacting with C2H5OH. This one is in aqueous state. This is a liquid. And what we are going to have here, remember, during the reaction between alkanoic acids and alkanols, water molecules are lost, and therefore this one hydrogen and the OH in the alkanol combine to form water. Whatever remains will be CH3, COO. We have CH3, COO, then C2H5, C2H5, which we call ethyl ethanoate. This is now our ester. So Roman 2 was asking, write the formula of the sweet-smelling compound, and the formula of the sweet-smelling compound will be CH3, COO, C2H5, and we call it ethyl ethanoate, which is an ester, plus of course water here, plus H2, or because we have the OH plus H from the acid, which gives us water in that particular manner. We go to Roman 3. Give one use of ethanoic acid other than the formation of sweet-smelling compounds. Apart from the formation of esters, ethanoic acid can be used as a solvent. Number 2, it can be used in the manufacture of drugs, and chemicals. It can also be used in flavoring and preservation of food. Flavoring and preservation of food. It can also be used to manufacture synthetic fibers. Synthetic fibers are simply man-made fibers. Roman 4. Write the equation for the reaction between dilute ethanoic acid and solid potassium carbonate. This is a carbonate reacting with an acid, and therefore you expect effervescence due to the production of carbon 4 oxide. In this case now, we are going to have CH3, COOH. This is ethanoic acid. Since it is dilute, it means it is in solution form. We add potassium carbonate, that is K2CO3. This one is in solution form. Then the reaction here will give us the potassium will come and displace hydrogen from the acid, such that we have CH3, we have COO, then we have K, which is aqueous, we call it potassium ethanoate. Plus we have carbon dioxide, which is a gas. And lastly, we are going to have water, which is a liquid. To balance the equation, we simply write 2 behind ethanoic acid, 2 behind potassium ethanoate, and the equation is automatically balanced. We move down to part D. Fibers are either synthetic, simply man-made, or natural. Give one example of a natural fiber. Examples of natural fibers include, we have rubber. We could be having cellulose, which is a major component of the plant cell wall, and it is a complex carbohydrate. We also have starch. We have wool, etc. Roman 2 of part D, we are supposed to give one advantage of synthetic fibers over natural fibers. We have several advantages here. We have several advantages of synthetic fibers over natural fibers. One is that synthetic fibers can be made into complicated shapes. 2, synthetic fibers are less expensive. We also have another advantage. One, they are not easily affected by acids. Not easily affected by acids, water, or air, among other advantages. We can also say it is stronger than natural fibers. So we have a number of advantages that synthetic fibers have over natural fibers. Thank you for watching and welcome to our channel. And in case you are watching this for the first time, kindly take 1 second and click the subscribe button so that anytime we produce a video like this, you'll automatically be notified.